We've refreshed our memory on how the atom is built. We are going to go through the basics of the periodic table. Periodic table is just a fancy way to organize all the elements by characteristics. And we spent a lot of time over various years putting it together, and what we found was that organizing it by increasing an atomic number is the easiest way to go. So what we've done is we've organized it into rows and columns. Each of the rows is called a period, and each column is called a group or a family. And I do want you to take a minute to notice that there are two rows underneath. These are what we call the lanthanides and the actinides, and they actually go smack dab in the middle of the periodic table. But the problem is the periodic table would be way too big if we actually did stick them in there. So what we do is we just pull them down to the bottom, and we tend not to use them too much in chemistry anyway, so they're not really needed that much, so we just stick them off to the side, and that way we don't have to worry about it. So there's several trends in the periodic table. You find that it's called periodic because you see the same characteristics popping up periodically every once in a while. So as you go across a row or down a group, so across a period or down a group, you will find that you have different trends that occur. The number one thing that you have is as you go from left to right across the periodic table, you're going to increase your atomic number. And the same thing's going to happen as you go down. Now as you go from left to right, it's going to increase by 1. When you start going down, it's going to be increasing by however many are in that period. Another trend in the periodic table is atomic radius. So atomic radius, for our intents and purposes for right now, is just the same as saying size of the atom. And effectively what will happen is as you go to the right across the periodic table, as you move to the right across a period, you're actually going to get smaller. And as you go down a group, you're going to get larger. We can get into the details of why this happens. If you would like to learn more about that, please see Ms. Corey. And we have one last trend we're going to take a look at, which is metallicness or metallic nature. So as you move to the right, elements become less metallic and more non-metallic. So we're going to talk about what a metal, a non-metal, and metalloid is. But as you can see here, that red area is all metals. We've got a little green staircase of metalloids, and then to the right of that is our nonmetals. There's lots more metals than there are nonmetals or metalloids. So what are our three types of elements? What is metallic nature? So we've got metals, nonmetals, and metalloids. Metals, as I'm sure you can probably determine just by thinking about aluminum or copper or any of these things, they tend to be good conductors. They reflect light well, which means that they're shiny. They're solids at room temperatures. Except for mercury, they tend to be solid at room temperature. They're ductile, which means that they can be drawn into wires, and they're malleable, which means they can be hammered thin. Nonmetals are basically the opposites of all that. Instead of being malleable, they're actually brittle and will shatter if you hit them with a hammer. Instead of being conductive, they are non-conductors, which means they make good insulators. Instead of being shiny, they're dull, and instead of being solids, they're gases for the most part. Metalloids, on the other hand, are somewhere in between the two, so they're not as shiny, they're not as good at conductors, they're not as brittle, they're not as dull. They're just kind of partway between the other two. Now we're going to take a moment to talk about families. So as we said, in groups, you tend to, you have two different organizations. You have periods and you have groups, and in our groups we tend to share similar characteristics. We're going to talk about is the alkali metals. The alkali metals are highly reactive. They are very soft. You could cut them with a butter knife and it would look very much like cutting butter. They float in water and they tend to react in water, so we get some fun reactions, and there will be a video available to you in Google Classroom that shows you some of those reactions. Here's our alkaline earth metals. These guys are still pretty reactive. They still like to do some reacting, but they're not as reactive as our alkali metals, and they tend to be harder and denser than the alkali metals as well. So on the right hand side. So these guys are non-metals. They're all highly reactive. You might have heard of like chlorine gas or fluorine glass. These guys like to react with everything. And most of them are caustic. They will burn your skin. And this is actually the group that also has the most rare element of all. And surprisingly, it's not ununceptium, but actually astatine, which is a naturally occurring element. It is just really, really rare. So these guys will burn your face off if you encounter them. And And finally, we have the noble gases. So these guys are nonmetals, and they really don't do much of anything. Other than radon, which is a little bit radioactive, these guys just pretty much don't like doing anything. They sit there, they hang out. They are the chill guys in the periodic table. So this is a chill family here in the noble gases. And that wraps up our discussion of the periodic table.